This is called Landau diamagnetism. It causes pyrolytic graphite to float on top of a magnet. But when you spin it, there's clearly some resistance that stops it from spinning due to the non-symmetries of the magnetic field. So what if we could float it on top of a symmetric magnetic field? Well, then we could get frictionless rotation. Look how cool this is. So the only thing slowing this down now should be the air resistance. So let's see if this will spin forever in a vacuum chamber. Okay, start. Okay, at a minute into it, it looks like it's still slowed down pretty significantly. 2 minutes, we're still chugging along. Okay, I'm gonna say it stops here. So we're at about 2 minutes and 58 seconds. So I was pretty frustrated at first. There's only a tiny increase in spin time, even at 0.1 psi. That's 99% pure vacuum. So why would that be? Well, this is where it got really interesting. If you look at the setup we have of a spinning disc above a magnet and look at the drag effect of air, at any pressure above 100 pascals, there's almost no dependence on pressure. So this regime where there's not pressure dependence is called the continuum flow regime. This means that molecules collide with each other much more often than with the surfaces. So drag depends only on the viscosity of the air, not the pressure. And the viscosity of air is basically constant across a wide range of pressures. In this paper where they did the same experiment as I'm doing here, they found no reduction in spin damping until they reached very low pressures, much lower than what I can reach here. But in their experiment, did it spin forever? Well, still no. At these very low pressures, the drag reached another plateau. And this comes from the fact that the magnets in graphite are not perfectly uniform. There are always slight defects that cause tiny eddy currents, and those eventually slow it down. So even though you can get virtually frictionless rotation at very, very low pressures, it still can't rotate forever. So alas, perpetual motion lies just out of reach, always.